Tetravalency of carbon, unique property of carbon, classification of chemical compounds, important role of organic compounds, distinction between organic and inorganic compounds, and elementary classification of organic compound and classification based on functional group. So, first to begin with, what is the valency of carbon? You know that the valency of carbon is tetravalent. In organic compounds, carbon exhibits tetravalency. When we write the electronic configuration of carbon 6, we know that it will be 1s2, 2s2, 2px1, 2py1 and 2pz0. When we look at this electronic configuration, there are only 2 unpaired electrons in the outermost shell, and therefore, it does not explain the tetravalency. How do you account for the tetravalency of carbon then? The carbon tetravalency can be accounted on the basis of excited electronic configuration and concept of hybridization that you have studied in the chemical bonding chapter. So, here when we take the ground state electronic configuration of carbon, we know that 2s2, 2px1, 2py1 and 2pz0. So, there will be a excitation of this electron, this one electron to the 2pz orbital. So, what happens when this take place? So, we have to see the electronic configuration again when the excitation takes place. Okay. So, this excitation takes place and this is excited state electronic configuration of carbon, and now there are 4 unpaired electrons in the outermost shell. Therefore, it can explain the tetravalency of carbon, and then depending upon the number of these half filled p orbitals that they can intermix with this s orbital, we can envisage different types of hybridization. If one s orbital intermix with the all 3 p orbitals, then it will produce 4 equivalent identical and equienergetic sp3 hybridized orbitals. Therefore, it is called sp3 hybridization. Similarly, we can explain sp2 hybridization, in which the only 2 of these excited electronic configuration orbitals of the carbon intermix with s orbital to form sp2 hybridized orbitals 3, and sometimes in some molecules only one s and one p, they will intermix to form sp hybridized 2 orbitals and so on. So, the hybridization you have already studied. Here 1 s, this 1 s and 3 p intermix, 4 sp3 hybridized orbitals are produced, and these hybridized 4 sp3 hybridized orbitals are at a regular 4 corners of a regular tetrahedron. Say this is a diagram which illustrates the intermixing, and there is a formation, there are formation of 4 sp3 hybridized orbitals, and this is found in case of methane, because methane is a best example of sp3 hybridized carbon atom, and these sp3 hybridized 4 orbitals of carbon overlap with the s orbital, 4 s orbitals of 4 different carbon atoms to form sigma bonds. 4 sigma bonds are formed, and the bond angle is 109 degree 28 minutes. So, it is tetrahedral molecule. So, this explains why the carbon is tetravalent, and it can also be seen this way. So, you have studied this in the all alkanes, wherein the carbon carbon single bond hydrocarbons are there. So, you have the sp3 hybridized carbon atoms there. 4 sp3 hybridized carbon atoms orbitals overlap with the 4 different hydrogen atoms to form a sigma bonds, and it is electron distribution diagram, and you have to draw this. This is above the plane, this is the below the plane, these two bonds are on the plane, and that is 3 dimensional figure of the alkane methane molecule with 4 sigma bonds. As with alkane, an electron from 2s is promoted to 2p orbitals, you have seen this. So, if out of 4 only 3 of them 1s and 2p are intermixing, you will get only 3 sp2 hybridized orbitals, one will be unhybridized, a single unhybridized 2p orbitals will be there. So, this is called sp2 hybridization, and here these are the sp2 hybridized 3 orbitals along the 4 corner of a triangle at an angle of 120, and this is unhybridized orbital perpendicular to these 3. So, we have the molecule called ethene, that is carbon carbon double bond, in which the carbon carbon sigma bond and remaining 2 of each carbon atom overlap with the hydrogen atom to form sigma bonds. So, therefore, in all there are 5 sigma bonds. See the 2 between the carbon and carbon of one carbon atom, and carbon and hydrogen of the second carbon atom, and carbon one sigma bond, therefore, and these two are unhybridized orbitals on the carbon atoms. So, they will undergo, these are unhybridized, and they undergo, these p orbitals of the carbon atoms are parallel and close enough to overlap sideway, and they do it so by forming the pi bond. This new bond is called pi bond, and more commonly it is pi bond formation. So, this is a molecule. A pi bond is a covalent bond formed by the sideway overlapping of 2 parallel atomic orbitals. So, it is not 2 pi bonds, it is 1 point bond, it is coiled, and here in between that you have a sigma bond. So, this unique property of carbon. So, unique property of carbon is catenation. What do you mean by catenation? The catenation means the formation of chain of identical atoms, or catenation is the self linking property of an element. Carbon atoms are able to combine among themselves infinitely to produce a wide varied types of carbon chains, short, long, straight, it may be branched, open, closed chain carbon atoms chains, and it can form huge number of molecules like this. It is a open chain, this is branched, this is closed chain hydrocarbon, and so on. Even sulfur as well as silicon belongs to the same group as that of the carbon in the periodic table. It can also form this self linking property, it can show, but sulfur can also show. However, if we observe the bond energy in kilojoules per mole, any carbon to carbon bond when it is formed, you know that energy is released, it is 347.4 kilojoules per mole energy, which is a huge energy, and therefore, carbon to carbon bond is stable. And when we see the silicon to silicon bond, it is 217.7 kilojoules per mole, and sulfur to sulfur bond can yield energy of 213.5 kilojoules of energy. So, energy liberated when these bonds, single covalent bond formed between carbon to carbon, silicon to silicon, and sulfur to sulfur decreases. That means, the highest energy means lowest energy state of this bond, that suggests the more stable carbon to carbon bond is formed. That is why this is one reason why the carbon compounds are very huge. In addition to the catenation, carbon can form a stable bonds with many other elements, because it is not possible to have more than 3 carbon to carbon triple, more than 3 bonds between carbon to carbon, and combine carbon atoms so as to restrict the carbon chain length. So, if we want to restrict the carbon chain length only 2, and there are only possible maximum bonds that can occur is 3, and the fourth must be with some other carbon atom or some other element. That is why hence carbon can form bonds with other many elements, which facilitates the carbon to form huge number of organic compounds. So, today's we are going to discuss this in detail, how are the organic compounds classified. So far we have found that there are huge possibility of organic compound formation because of a unique property of carbon and its ability to combine with other atoms to form chains. So, therefore, as we have already seen, now we will discuss the classification of chemical compounds and important role of organic compounds. So, chemical compounds means all together, it may be organic or inorganic. So, the broad classification is organic compounds, we can classify it into 2 categories, chemical compounds, organic compounds and inorganic compounds. So, these are binary compounds of carbon and hydrogen and their derivatives. The organic compounds are nothing but they are binary compound. Binary means 2, they are, that is carbon and hydrogen can form huge number of class of compounds called organic compounds, and these are say food what we take, they are composed of carbon compounds and then hydrogen or their derivatives, and fuel what we use, the plants, the fruits, the drug, medicines and the cloths what we wear, everything is made up of organic compounds. Where do we find inorganic compounds and how are they defined? Inorganic compounds are all other chemical substances other than binary compounds of carbon and hydrogen and their derivatives, except the organic compounds what we have, rest of them are inorganic compounds. For instance, minerals what we take, so they are and cement what we use. So, like that we have many inorganic compounds as well. Then what are organic compounds? We will reiterate once again, the organic compounds are simply binary compounds of carbon and hydrogen and their derivatives, sometimes we may have some other compounds like carbon, hydrogen along with the oxygen. So, we are going to detail when we make the classification and so on. So, organic compounds make up living bodies. So, human being, plants, animals and foodstuff what we take. So, and dyes what we use for clothes or elsewhere. So, fuel what we use and almost everything of daily life. So, they are made up of organic compounds. So, books what we use, furnitures from wooden furnitures what we get. So, food, the nature, whether it is a birds, whether it is human beings, whether it is everything in and around us, we have organic compounds. So, how do you distinguish the organic and inorganic compounds? Organic compounds and inorganic compounds can be distinguished very clearly. Number 1, organic compounds are generally covalent compounds and essentially contain carbon, hydrogen as constituent elements, essentially contain carbon, hydrogen. So, in addition to that there may be some other atoms like nitrogen, sulfur and sometimes metals also come, but essentially organic compound composed of carbon and hydrogen. And in the inorganic compound it is not necessary that the carbon and hydrogen must be present, and most of the inorganic compounds are generally ionic compounds. they are ionic. For example, common salt, it is soluble in water, ionic compound. Yeah. These compounds, organic compounds, have low density, melting point, low boiling point and low solubility in water. Since covalent compounds, so they are probably soluble in water due to the hydrogen bond formation, or else they are insoluble in water. However, most of the inorganic compounds are water soluble, they have high density, high melting point, high boiling point. So, this is one important distinction. Then other important distinction is the organic compounds are more susceptible to undergo oxidation. For example, if we prepare food, it may undergo decomposition quickly due to aerial oxidation. Okay. So, or else it develops some bad smell, which may be useful for us, may not be useful for us, but anyway the organic compounds are susceptible to undergo oxidation. However, inorganic compounds, for example, if we keep this salt for a say a longer period of time, nothing will happen unless and until it comes in contact with water or something else. So, these are less susceptible to undergo oxidation. And if we carry out a reaction with organic compounds, they are generally not instantaneous, they are not fast enough. Whereas, inorganic reactions, you must have done that when the silver nitrate is added to sodium chloride, instantaneous white precipitate of silver chloride will be formed, and that is due to the ionic interactions in the solutions. Whereas, organic compounds are involving covalent bonds, the breaking and formation requires certain time, therefore, they are not instantaneous reactions. So, there are some organic compounds, there we will find quite number of times we will come across isomeric compounds of in case of organic compounds. Isomeric means they have same molecular formula, but they have different chemical properties and structures. So, therefore, such type of compounds you quite oftenly see in the organic compounds, whereas in case of inorganic compounds these isomeric compounds are very rare. There are some compounds wherein you can have the isomerism in complex compounds. So, the detailed study is beyond the scope. So, I am just skipping. Therefore, you got to remember only the differences between the organic compounds and inorganic compounds. So, how we can classify these type of organic compounds? That is the main central point of discussion today's lecture. So, we can make the classification of organic compounds into two categories. One is elementary classification. The existing large number of organic compounds are classified on the basis of structures as follows. Organic compounds, first and foremost, we can classify it into two broad categories based on their structures. If they have open chain structure, as we have studied in the last slides, they are called as acyclic or open chain organic compounds. And if they have closed stripe, there are no ends to, then they are called as acyclic or closed chain organic compounds. So, then alicyclic compounds can be further classified into saturated, wherein the carbon valency is 4 valency, tetravalency is totally satisfied by 4 different groups or atoms. So, if not, then they are called as unsaturated. So, acyclic or open chain organic compounds can be classified into two categories, saturated and unsaturated hydrocarbons. And acyclic or closed chain organic compounds can be classified into two broad categories. One, homocyclic means there is a closed structure, homo means they have same type. So, carbocyclic compounds, and there are some other compounds, organic closed chain compounds, which can have the, in addition to carbon as a member of the ring, they can have nitrogen, oxygen, sulfur as member of the ring, and such type of compounds are called as heterocyclic, because the heteroatom here we mean foreign element. Foreign element, because we are looking at organic compounds, as I already told you, they are mainly composed of carbon and hydrogen. So, here in the cycle, in the ring, you are also finding a foreign element like nitrogen, sulfur, oxygen. Therefore, it is a foreign element and which makes the part of the ring. Therefore, they are heterocyclic compounds. We are going to take up the examples as we proceed further. Two more clarification, for more clarifications. So, acyclic, the homocyclic or carbocyclic hydrocarbons or organic compounds can be further classified into alicyclic compounds. Look at this alicyclic, here acyclic, there are some properties of this compound, though they have a closed chain structure, they resemble certain respect about the chemical properties to that of acyclic compounds. So, therefore, they are alicyclic compounds and aromatic compounds. Aromatic compounds, the word aroma means sweet smell. It is a misnomer, because in when the in the earlier days it was found that most of the organic compounds found which have ring structures, they have sweet smell. Therefore, they called it as aromatic compounds, but it is now definition being changed and it is misnomer, because definition has been changed, the name has been retained. So, that is the compound which follows the Huckel's rule, and that is organic compounds for 4n plus 2 the pi electrons. The detailed study is not required insofar as the first semester diploma classes are concerned. Therefore, I am avoiding that. However, there are compounds which are homocyclic and or carbocyclic, which are called as aromatic compounds, which can be further classified into benzenoid aromatic compounds and non-benzenoid aromatic compounds. Benzene is one typical and best example of aromatic compound, and if their structure resembles, they are called a benzenoid. If not, they are non-benzenoid, but still they are following the aromatic conditions. Okay, that is the reason why they are called as non-benzenoids. Then the non-benzenoids, next we will go to the classification of organic compounds. As I told you, there is a organic compounds possessing open carbon chain are called open chain or acyclic compounds, or more commonly aliphatic aliphatic organic compounds. So, binary compounds of carbon and hydrogen are called hydrocarbons, and their derivatives all put together, they are organic compounds, which we have defined earlier. But for simplicity, let us consider the classification of hydrocarbons first, and the derivatives of hydrocarbons can also be classified on the basis of their functional group. So, we can say that the organic compounds can be broadly classified on the basis of two things. One is, if they are comprises of carbon and hydrogen, then they are hydrocarbons. So, hydrocarbons classification. Similarly, if they are having certain functional groups which we are going to define shortly, and on the basis of functional groups, other organic compounds can also be classified. So, the criteria is that whether the carbon chain as well as functional group, two criteria on which the organic compounds can be classified. So, first we are discussing the classification of purely hydrocarbons. They are binary compounds of hydrogen and carbon only. Thereafter, we will take the classification which are based on their derivative, means functional groups as well. So, if we classify that, these are the classification. Hydrocarbons can be classified into two categories, acyclic as we have seen in the previous slide, here organic compounds, here hydrocarbons, acyclic or open chain hydrocarbons, or cyclic or closed chain hydrocarbons. So, there are two things again, acyclic hydrocarbons can be classified into saturated and unsaturated. What are saturated? Here all n number of carbon atoms that are present in the given hydrocarbon. I just recollect or reiterate hydrocarbons classification we are seeing. Therefore, these are the compounds of carbon and hydrogen only, and these saturated hydrocarbons, if you have n number of carbon atom in a given chain and there will be 2n plus 2 number of hydrogen atoms attached to this in a chain, and there will be carbon to carbon single bond and carbon to hydrogen of course single bond satisfying each 4 valency of the carbon in the given hydrocarbon chain, and this type of class of compounds, all n number of carbon atoms present in the hydrocarbon, they are all sp3 hybridized carbon atoms. There are no sp2 or there will be no sp3 there will be no sp2 and sp hybridized carbon atoms in such hydrocarbon chain. So, they are saturated. In simple we can say there will be a chain of carbon comprises of n number of carbon atom, all of them are joined through single bond, single covalent bond, and rest of the valency each of the carbon atom are satisfied by as many as 2n plus 2 number of hydrogen atoms, and they are called as saturated hydrocarbons. You can quote the examples of methane as we have seen earlier, ethane. So, homologous series which have the general formula CN H2n plus 2, and there are other class of hydrocarbons in which we can find either one double bond or one triple bond in a given chain of hydrocarbon. So, they are called as alkenes if you have one double bond, and if you have one triple bond then it is called alkyne. Their general formula CN H2n alkenes, and alkynes have general molecular formula CN H2n minus 2. So, both of them are under unsaturated because the 4 valency of carbon of at least 2 carbon adjacent carbon atom in a hydrocarbon chain are not fully satisfied. They are forced to undergo satisfy by themselves by formation of pi bond. So, which we have seen the last slides. So, these are all open chain hydrocarbons, and there are closed chain hydrocarbons as well. Here we have closed chain hydrocarbons can be classified into homocyclic and heterocyclic. Homocyclic can be further classified into acyclic compounds, aromatic compounds. Aromatic can be benzenoid aromatic, non-benzenoid aromatic compounds. We are going to take up all the examples and how are these classifications are taking place, including the functional derivative later on. So, classification of organic compounds, and here as I told you, the first saturated hydrocarbons, alkanes, those aliphatic organic compounds containing carbon atoms linked through single covalent bonds in the chain, and that is all carbon atoms in a chain are sp3 hybridized. These hydrocarbons can be represented by general formula CN H2n plus 2. For example, you have studied in your early classes as well methane, ethane, propane, butane, etc. This is a series of hydrocarbons wherein they can be represented by one general formula. They have constant differences in the among the family members, and they have similar chemical properties and some gradation in their physical properties. As the atomic molecular mass increases, there will be some gradation in their physical property. Otherwise, more or less chemical properties of these organic compounds which are classified under the alkanes will have same chemical properties. they undergo nucleophilic substitution reactions